Welcome to a world where chemistry gets smarter, safer, and more sustainable. In today's video, we are diving into the fascinating realm of microscale experimentation, a revolutionary approach that uses minimal chemicals, ensures maximum safety, and offers clearer learning. So let's jump into five brilliant experiments, small in scale, big on impact. Watch carefully, we won't reveal what's happening right away. In this first experiment, we take a wooden matchstick, wet it, and roll it over sodium bicarbonate, and then immediately roll it over red powder, which is iron oxide. Once it is rolled, we gently heat it on candle flame and collect the residue to a paper. Remember to use a wooden matchstick. Now roll the paper and gently tap it on it to crush the residue. Once the residue is finely crushed, take a bar magnet and place it under the paper and see what happens. You will see some of the black particles moving here and there. It has been attracted towards the magnet. What do you think is that black residue which is being attracted towards the magnet? This same process is also used in the blast furnace. This same method is also used in the blast furnace to obtain iron. Now, I hope you understood what is the reaction, what is happening here. Let me know your answers and why do we use wooden matchstick only. Now, this is the second experiment, which is electrolysis. Now, drop a few drops of water at the center of the petri dish, add NaCl, which is common salt, and mix it properly so that the entire salt is mixed in the water and you get salt solution. Now, instead of using phenolphthalein, which is a synthetic indicator, we can use turmeric, which is a natural indicator. Now, the solution turns yellow because of turmeric. Now, use a 9-volt battery to 2 mm LEDs, crocodile clips, and make the electricity setup. Connect the battery. Now, carefully, with the help of the crocodile clips, pass electricity to the solution and see what happens. As soon as the electrodes touch the solution, you will see that there is a bubble formation at both the sides, and also at one end there is a color change formation from yellow color to reddish brown color. What just happened here? What is being broken down? Next, we have double displacement reaction between lead nitrate and potassium iodide. We drop few crystals of lead nitrate, which is white in color, and then few crystals of potassium iodide, which is also white in color. When we combine them with the help of a water bridge, see what happens. As soon as both the crystals touch with the help of water, there is a formation of yellow intermediate precipitate being formed. What is that golden precipitate and why does they form so fast? Next, we have enzyme catalyzed decomposition reaction. Here, I'm taking hydrogen peroxide, which is 3%, and adding few drops into the center of the petri dish. Hydrogen peroxide is a disinfectant, antiseptic, and used as bleaching agent. To this hydrogen peroxide, we will add a small piece of potato. After few seconds, you will see a formation of bubbles in and around the potato. This is the decomposition happening with the help of enzymes present in the potato. Next, we will see single displacement reaction. Add few crystals of copper sulfate and 2 drops of water and make a copper sulfate solution. To this solution, if you remember in the first experiment we had obtained iron. Collect that iron and put it in the copper sulfate solution. This was the iron that we obtained in the first experiment, reduction of iron oxide. Iron being more reactive than copper, it displaces copper from copper sulfate solution and you can see the reddish brown residue obtained of copper. This is single displacement reaction. Could you please let me know all your answers?